So to look at 45, 45, 90 triangles, we start with a square of size 1, right? Everybody loves a square. It's like the simplest shape you can deal with, right? So here's a square. Each side is 1, and each of the angles in the square is 90 degrees, okay? Now, what we're going to do is, with this dashed line, we're going to cut the square into 2, right? So now here I have 90 degrees. And when I draw this diagonal, it bisects this triangle, this angle here. So each of these is 45. And then also here, so that one is 45. And so what you have now at the bottom is a 45, 45, 90 triangle. Now what I want to do is I want to find this diagonal. But you know what? I want to find it using the Pythagorean theorem, okay? And we can do that because its legs are 1 and 1. So it's 1 squared plus 1 squared is equal to x squared. 1 plus 1 is 2 equal to x squared. So when I take a square root, x is just root 2. So this is root 2, okay? So what do we notice here? If these legs are 1, this is 1 times root 2. Now, what if we had a different square? What if we had a different square and this time the sides were 3 and 3, not 1 and 1? Let's do the same thing. Okay, diagonal. This makes it a 45 and this makes that a 45. Let's find x now. So now what are we going to do? 3 squared plus 3 squared equal to x squared. Okay, so that's 9 plus 9, 18. Now when I take a square root, x is what? It's root 18, but can I leave root 18 as root 18? How can I simplify it? Let's see, 18, factor, right, you do the factor tree, so it's 9 times 2. And then this is 3 and 3. The 3's, whichever has a pair, comes out of the root. Whichever doesn't have a pair, the 2 stays in the root. So this will be 3 root 2. Okay, and do you see we did it by the Pythagorean theorem with a different side length, and we got the leg times root 2. And you can do it with any side length of a square. You would always get the leg times root 2 for this side, even if you did it in France, even if you did it in the southern hemisphere, right? So that tells us that in a 45, 45, 90, the length of the hypotenuse is root 2 times the leg, okay? So this you have to memorize. The hypotenuse is root 2 times the leg. So that means if I'm solving for the leg, what would it be? Not 1. So if I solve this highlighted equation for the leg, I would have to divide both sides by root 2, right? So it would be the hypotenuse over root 2. Okay? All right, why don't we do some examples here? We need to find, x and or y. So here, these are the legs. How much is x? 4 root 2. There is pretty much no math for that one. Just write it in. Okay, here, this is the leg and this is the hypotenuse. What I want you to always do is the following. Hypotenuse equals leg times root 2, right? This we know to be true. Now, let's fill in what the labels are for the hypotenuse and for the leg. In this problem, the hypotenuse is an x. The leg is a 5 times root 2. Okay, so this will be 5 root 2. Okay, now, you can do it this way, or you can just do it in your head. I don't care as long as, right, that works out. Okay, in this case, now we're missing the leg. right? So let's do this. Hypotenuse equals leg times root 2. What's the label for the hypotenuse here in the diagram? 3 root 2. What's the label for the leg? X times root 2. So we have to solve for x, right? So what do? Divide both sides by root 2. So how much is x? 3. Now, somebody might be like, okay, Mrs. Malikan, I could have totally seen that just by looking at the diagram. Good for you. So then just write 3. But if you can't see it, go through the process, because guess what? The process will never fail you. Cool? Okay. Here, hypotenuse is leg times root 2. How much is the hypotenuse? How much is the leg? Times root 2. So how much is x? Is it 5 root 2? Okay. So x is 10 over root 2. You can totally leave it like that. You can. Remember what we said. You can leave it like that as long as the root is simplified. Like as long as it's not root 18 or root 24. Now, if you want it to simplify or to rationalize, then it would be 5 root 2, but you don't have to go that far. However, both will be counted as correct. Okay, so here, hypotenuse is leg times root 2. What's the hypotenuse? Right, x is 6 root 2. Okay, what about this one? The hypotenuse is leg times root 2. Do you see how when I write this, it never confuses me, right? So I just, like, whatever is marked, I put it in there without even thinking. Hypotenuse is x. What's the leg? Root 6. And then times root 2. Yes, now it's going to be root 12. But can we leave it like that? No. So 12 is 4 times 3, 2 and 2. So what's x? 2 root 3. Okay, please ask me if you have any questions. Ask me now. Really good since I started doing math. Yeah. Okay. Here we go. How much is x? 5 root 2 because they are equal, right? Now, the hypotenuse is the leg times root 2. Okay, don't get confused between the root 2's. I purposely made it a root 2 over here. So y is 5 times, right, root 2 times root 2 is just 2. It's root 4, which will be a 2. Okay, so this is 10. Y equals 10. So remember, root 3 times root 3, how much? Root 3 times root 3, it's root 9, which is a 3, right? So how much is root 11 times root 11? 11, right? So how much is root 12 times root 12? 12. If I have root table times root table, table, right? Root chair times root chair, chair. Okay? All right. Okay. Maddie. Right. Okay. So let's do this one. Here I have a hypotenuse. I need to find the leg. So remember, the hypotenuse is leg times root 2. Okay. How long does it take you to write that? A fraction of a second. So just write it and save yourself the trouble, okay, of getting it wrong. So hypotenuse is 20, leg, root 2, divide by root 2, divide by root 2. You can leave it 20 over root 2. 20 over root 2. Why? Same thing. Okay. So take a look here. Determine whether there is enough information to conclude that the triangle is a 45, 45, 90. Right? Uh-huh. Well, this is just yes or no. So sometimes, so like for example, this one, you don't have any angles given to you. And over there, you don't have any sides given to you. So what do we know about a 45, 45, 90? We have an angle, and then what do we know about the other two angles that are not 90? They have to be the same. So in this problem, A, are those two angles the same? Yes. They are. They're both x and x, right? So yes, this is 45, 45, 90, because these are the same. So basically, a 45, 45, 90 is isosceles, right? How many sides are congruent in an isosceles triangle? 2. Okay, so take a look at this one. Does that qualify as an isosceles? Yes. And there is a 90 degree. So this is also a 45, 45, 90. All right. If you don't have enough information, you can't go and do this calculation at all. Okay. So now, how do we come across, how do we get our formulas for the 30, 60, 90 triangles? Well, here we have an equilateral triangle. All sides are equal. If all sides are equal, all angles are also equal. How much is all three of the angles equal to in a triangle? 180. So if all three of these angles are 180, if you split 180 into the three, each one of these is going to be 60 degrees. Okay, now guess what I'm going to do? I'm going to split this into two equal triangles with an angle bisector. So now this bottom angle is 60 degrees. But now this one that was 60 before now gets split, and each of those are now 30. So this is 30, and over here, that's a 90 degree. So what I have over here now is a 30, 60, 90 triangle. Right here, if I just take this, that's a 30, 60, 90 triangle now. Okay, now, this diagonal side is 2. The bottom side was 2, but when I split it down the middle, now this is a length of 1. And I need to find this side. Okay? All right. Now, can we use the Pythagorean theorem on that blue triangle? Is it a right triangle, that blue one that I highlighted? Yes, right? This is a right triangle. So why don't we use Pythagorean theorem and find that side? So it's going to be x squared plus 1 squared equal to 2 squared. X squared plus 1 equals 4. X squared equals 3. X is root 3. Okay? All right. So let's think about this. This blue triangle is a right triangle. This one here is the hypotenuse, right? Now I have 2 legs. This one is the shorter leg. It faces the smaller angle of 30. Hey, what happened there? Too much math for the projector. Oh, if only. Okay. This is the longer leg. It faces the 60-degree angle, right? So let's draw a cleaner version here. This is 90 degrees. Here we have the hypotenuse. One of these angles, we'll make it, this one is 30. It faces the short leg. The other angle is 60. It faces the long leg. Okay? Now, what's the formula? The hypotenuse is the short leg times 2. The long leg is the short leg times root 3. So this is what you need to know for this. Hypotenuse is 2 times the shorter leg. Longer leg is root 3 times the shorter leg. All right? So we need to just memorize those. Okay. Here we go. Find the length of each missing side. Now listen. Take a minute. Label these. This is the hypotenuse. Is the 7 the short leg or the long leg? Short leg. Short and hypotenuse, how are they related? Hypotenuse is 2 times short. X is 2 times 7, 14. Okay? All right. Here we go. What's the 3? Hypotenuse, short or long? Short. What's the 60? Hypotenuse or long? Long. So the players in this problem are short and long. Well, the long leg is the short times root 3. So now let's label x 3 times root 3. If you do it this way, there is very little chance that you'll get things confused. Okay? Okay. Okay. What's the x and what's the 10? Correct. And we know long is short times root 3. X is 10 times root 3. So this is 10 root 3. The biggest mistakes I get for these is students don't want to write this stuff down and then they have a different configuration. So for example, they'll write 10 divided by root 3 instead of 10 times root 3, right? Because they thought they got the order wrong. So just write it out. Okay, go ahead and do the next one. Just write out the answers for the next one. Okay, so for the next one, we have x and y. So what we're going to do is we're just going to take one of these triangles. Okay, now you see that the y is the hypotenuse, the 12 is the long leg, and then the short leg is this one here, right? I'm going to call it A, right? It's just that little part. X is much bigger. That's just A. So now, okay, we have the long. Let's find the short. Long is short times root 3. So 12 is A times root 3, right? Now, how do we find A? By root 3. So 12 over root 3 is A. Okay, great. But we don't even want A. How does X relate to A? It's 2 times. X is 2 times 12 over root 3. Remember, this is over 1. So X is 24 over root 3. Okay. What about y, the hypotenuse? Y is short times, right, times 2. So y is, how much was the short leg? 12 over root 3 times 2, same thing. Correct. Okay? All right. So next one, okay, I'll do the first one and then you're going to do the rest yourself. So here we have x is short. This is long. And we have the hypotenuse. Which formula are we going to start with? The hypotenuse. Because you're given the hypotenuse, that's what you start with. So hypotenuse equals short times 2. 8 equals x times 2. X is 4. And then how much is the longer leg? 4 root 3. Okay. Next, take a minute and do B, C, and D here, please.